Assalamualaikum and hi, we are group 9 for CST435 for the subject parallel and cloud computing. So this is our assignment 2 presentation, which is about image processing pipeline. So my team members are Arif, Ikmal, Zarib and myself, Ahmad Hazwan. So today we will demonstrate our pipeline comparing sequential, multiprocessing and threading implementation. For our environment, we deployed a virtual machine on Google Cloud Platform. Right now, you can see here is the VM that is running for our assignment. And as you can see here, the machine type, we are using the E2 standard for instance. We chose this because it has 4 vCPUs, which allows us to effectively demonstrate parallel performance. So now let's run the SSH terminal. And you can open this terminal by clicking the button SSH here. I already have mine open, so let me just open it. So right now I am connected to the VM via SSH. So first, I want to verify our virtual environment is active. So what we need to do is type this. So now what we want to do is to run the benchmark. So what we need to do is type this. So right now I am running the automated benchmark script. So first, it runs the sequential version, which is the baseline. So this one runs on a single core. So after the sequential is done, now it runs the multiprocessing. So for multiprocessing, it uses separate memory spaces to bypass the global interpreter lock. So it allows true parallelism on all 4 cores. So it will take a time. So finally here, it runs the thread pool executor. Although Python threads are usually limited by the global interpreter lock, OpenCV releases the lock during heavy calculations. So we still see some speed up. So now we just have to wait for it to finish. The benchmark is complete. So what we need to do now is to zip and download the results for analysis. And to do that, we must click the download file button here and put these 2 paths and then click download. Here are the results from the benchmark. Looking at the execution time, the sequential put took about 25 seconds. The multiprocessing was the fastest, taking only 9 seconds. We also have a process pool which is just a second behind multiprocessing, took about 9.2 seconds. And the threading version took about 11.6 seconds. So this gave us a max speed of 2.8 times, proving that multiprocessing is the best strategy for the CPU heavy task. At the end, we gained several key insights. The first one being Amdahl's law. Even with 4 cores, we did not get 4 times speed up. We got 2.8 times. This is because of overheads and the sequential parts of the code, like reading images from the disk. The second one is strategic trade-offs. So process-based parallelism is faster but uses more memory. Thread-based is lighter but struggles with the Python GIL. The third one is a cloud deployment. So deploying on GCP taught us how to manage cloud resources and ensures our benchmarks are reproducible. Finally, here is the visual check. On the left is the original, and on the right is the output with grayscale, blur, and edge detection applied. This means the pipeline works successfully. Thank you.